Alright, we're going to be taking notes today over 5.3, which is writing equations or inequalities for given graphs and applications. And one of the things I want to let you know is that it is the same as the equalities. In the fact that we need to find the slope, which is m, and the y-intercept, which is b, to write the inequalities. I need you to remember from previous lesson that if we had less than or greater than, our line was dotted. And if we had less than or equal to or greater than or equal to, our line was solid. Our first example here, we want to find slope and we want to find y-intercept. And we find slope by calculating the distance between the 2 points. We could pick any of these 2 points on our line. So I'm going to pick this one. I'm going up 1 and running to the right 2. So my slope is 1/2. And my y-intercept is starting at 1. So I'm going to start writing my inequalities. So I'm going to have y. I'm going to leave the inequalities space blank at the moment. 1/2 x plus 1, because I need to know that it is a dashed line. It is a dotted line, which tells me it's going to be less than or greater than. And how do I tell which one to use? Well, I'm going to look at the shading. Here's my line. If my shading is above my line, it's greater than. If the shading is below my line, it's less than. And since my shading is below my line here, it is going to be less than. So I'm going to fill in my inequality with less than. And my inequality is going to be y is less than 1/2 x plus 1. My second example, I'm going to go ahead and calculate the slope and find the y-intercept. So again, I can use any 4 of these points. So I'm going to start here and I'm going up 1, 2, 3 units and to the right 2 units. So my slope is going to be 3/2. And my y-intercept, I'm starting up at 4. The y-intercept is where your line crosses your y-axis. So I'm going to go ahead and start writing my inequality. I'm going to skip the inequality part. So it's going to be y, and I'm going to have 3/2 x plus 4. Now this time I have a solid line. So my solid line is going to be less than or equal to or greater than or equal to. Again, I'm going to look at the shading. My shading is below my line. So being that it's below my line, it's going to be less than or equal to. So my final inequality becomes y is less than or equal to 3/2 x plus 4. My third example, I'm going to find my slope. I'm going to find my y-intercept. Again, I have 4 points to choose from. I'm going to start here. I'm going to go up 1 and to the right 4. So my slope becomes 1/4. My y-intercept, I'm starting down at -2. So my y-intercept is down at -2. I'm going to have y, skip my inequality part right now, 1/4 x minus 2. And I'm going to look at my shading. I do have a dotted line or a dashed line, so I know it's going to be less than or greater than. And my shading this time is above the line. So if it's above the line, it's going to be greater than. So my inequality becomes y is greater than 1/4 x minus 2. Okay, my fourth example, I'm going to calculate my slope, calculate my y-intercept. So again, I've got 3 points on this line to choose from. So I'm going to start here and I'm going down 1, 2, 3, 4, 5, 6, 7 units. Down 7 means it's a -7, and to the right 2. So my slope is going to be -7/2. And my y-intercept is starting up at 1. So starting to write my inequality, I'm going to have y, I'm going to skip the inequality part, -7/2 x plus 1. I do have a solid line, so that means it's going to be less than or equal to or greater than or equal to. So if I'm looking at my line, my shading is below my line, so that means it's going to be less than or equal to. So my inequality becomes y is less than or equal to negative 7 over 2x plus 1. My fifth example here, I have a vertical line. We should be very familiar with vertical lines. It has an undefined slope, which means the equation starts with x. And where is this line going through x? It's going through x at 1. I do notice it is a solid line, so it's going to be less than or equal to or greater than or equal to. And I want to check at 1. Is my shading greater than 1? Or is my shading less than 1? And we can see all of our shading is to the left side, so it's less than 1. So my inequality is going to be less than or equal to. So my inequality becomes x is less than or equal to 1. My sixth example, it is a horizontal line. It means it has zero slope. So that means we know it's going to start with y. And it's crossing my y up at 2. It is a dotted line, a dashed line, so that means it's going to be less than or greater than. And where's my shading? My shading is greater than the line. It's above the line. So y is greater than 2 becomes my inequality. Okay, I'm going to zoom out for number 7. You are going clothes shopping and can spend at most $130 on clothes. It costs $30 for a pair of pants and $22 for a shirt. Let X represent the number of pants you can buy and let Y represent the number of shirts you can buy. Write an inequality that describes the different number of shirts and pants you can buy. Well, we have $30 for each pair of pants, and that pants was represented by X. And we can pay $22 for each shirt, and each shirt is represented by Y. Now we can spend at most $130. So that means this purchase cannot be over $130. So that means that my purchases have to be less than or equal to $130. And this is our inequality. 30x plus 22y has to be less than or equal to 130. Part B, can you buy 2 pants and 2 shirts? Why or why not? How much does it cost? So we'll need to answer each one of these questions. So can you buy 2 pants and 2 shirts? Well, let's see. We've got $30 times the 2 pants plus $22 times the 2 shirts, and we need to see if that's less than or equal to 130. So we want to grab the calculator. And I need to do 30 times 2 plus 22 times 2, and I get 104. So I get 104 is less than or equal to 130. So can I buy 2 pants and 2 shirts? Yes. Why or why not? Why? The cost is under $130. Okay, well, how much does it cost? Well, it's going to cost us $104. So I know I've answered all 3 of my questions. Does the point 41 satisfy the inequality? What does the ordered pair represent? Well, if you'll remember, our x's represented the pants and the y's represented our shirts. So that means that our ordered pair represents 4 pants and 1 shirt. Does it satisfy the inequality? Well, let's see. $30 times 4 plus 22 times 1. Is that less than or equal to 130? Well, let's see. We pull up the calculator again. 30 times 4 plus 22 times 1 gives me 142. Is 142 less than or equal to 130? And the answer is no, it's not. So it does not satisfy our inequality. Suppose you decide to only buy shirts. What is the most that you can purchase with the money you've been given? Okay, well, this is our y-intercept basically. So I can only buy 22 shirts, so I only have $22 per shirt. So I get 22y, and all of that money has to still be less than 130. So that means in order to solve for y, I'm going to divide by 22, and my y has to be less than or equal to, calculator time, 130 divided by 22 gives me 5.90 repeating. 5.90, and put my bar over it for repeating. Now, let's look at the reasonableness of this. Have you ever bought 5 whole shirts and 9/10 of another? No. You can only buy 5 shirts, or you can buy 6 shirts. Well, in this case, I can't actually buy 6 shirts because I can't just go get 9/100 or 9/10 of a shirt. So our inequality is going to have to reflect that as far as our answer goes. So I can buy less than 6 shirts, or I could buy 5 shirts or less. Since I can't actually go up to 6 shirts, less than goes up to 6 but doesn't include it. So that would include 5, 4, 3, 2, 1, 0 shirts. Y is less than or equal to 5. Well, I can buy 5 shirts because I can go over 5. I just can't go up to 6. So either one of these inequalities would work that are reasonable based on our given problem situation in the number of shirts. Okay, number 8. You have a summer job and make $25 for mowing lawns and $15 for clipping hedges. You want to earn at least $500 over the summer. Let X represent the number of lawns you mow and Y represent the number of hedges you clip. Write an inequality that describes your desired income for part A. Well, you are getting paid $25 for each lawn, so that's X, and $15 for each hedge, that's Y, and you want to make at least $500. So the amount you get paid needs to be more than or equal to $500, greater than or equal to $500. What is the x-intercept of the equation? Well, we want to keep the x variable, which means we're not going to have a y. So that's going to be 25x is greater than or equal to 500. Well, if we solve for that, we're going to have to divide both sides by 25. So I'm going to grab my calculator. And we're going to take 500 and divide by 25. So that means my x-intercept, my x is going to be greater than or equal to 20. Well, what does that mean though? Well, the x represented the number of lawns he mowed. So that means he's going to have to mow 20 or more lawns to earn over $500. So he's going to have to mow at least 20 lawns to get the $500 just by mowing the lawns alone. Does the point 16.5 satisfy the inequality? What are your total earnings? Well, let's see, we get paid $25 for each lawn, so we have 16 lawns that we're mowing, and we get paid $15 for each hedge that we clip, and we have 5 hedges, and I want to see if that's more than or equal to 500. So, grabbing our calculator again, I've got 25 times 16 plus 15 times 5, and that gives us $475. Is $475 greater than or equal to 500? No, it's not. So it doesn't satisfy our inequality. And what's our total earnings? Our total earnings are $475. What does the point 1313 mean in this situation, and does it satisfy the inequality? Well, it means he's going to mow 13 lawns and clip 13 hedges. Does that satisfy our inequality? Well, let's see. We've got $25 per lawn, so we've got 13 lawns, and $15 per hedge. We've got 13 hedges, and we need to see if that's greater than or equal to 500. So grabbing our calculator again, we've got 20. Okay, we're about to see if 1313 satisfies the inequality. So we already wrote it into the equation, so I just need to type it in the calculator. 25 times 13 plus 15 times 13, that gives me 520. So does 520 greater than or equal to 500? Yes, so it does satisfy our inequality. Okay, I'm going to zoom in for 9a. Solve and graph the solution set on the number line. So I need to solve for x here. I have a multiple step problem because I have x's on both sides. I need to move my x's to one side of the equation. I need to move my x's to one side of the equation. So I'm going to take my smaller x, which is negative x, and move it to my left. And to do that, I got to do the opposite. So I've got to add x to both sides, and that eliminates it here. So I'm left with 5x plus 14 on the left side is less than negative 16. And then I need to move my 14 over to the right side because we typically have variables on one side, constants on the other. So I'm going to do the opposite operation here. So that's subtract 14. That eliminates it here. And I get 5x is less than negative 30. And then I still have to get rid of this 5. 5 is multiplied to x, so the opposite of multiplying by 5 is to divide by 5. And I get x is less than negative 6. Okay, well now I need to draw a number line. And I'm going to put negative 6 in the middle, and I'm going to put numbers on either side. And x is less than 6, so less than means it's an open dot. And x is less than 6 means I need to go for the smaller number, so that's going to be to the left side of negative 6. And here's my number line. Part B, I need to do some simplifying first. I have this negative 5 that's being distributed to x plus 4, and yes, you take the number and the sign in front, so I need to distribute that. So I'm going to multiply that through, and I'm left with 3x, and I get negative 5x minus 20 is less than or equal to 8. Then I need to further simplify by combining like terms because I do have these two x terms on the same side, and that gives me negative 2x minus 20 is less than or equal to 8. And then I've got my x term over here on the left, so that means I need to move my constant over to the right, and to do that I'm going to do the opposite, so I'm going to add 20 to both sides, and that gets rid of the 20. And I'm left with negative 2x is less than or equal to 28. Then I've got to multiply by negative 2, so the opposite of that is to divide by negative 2, and I have things going off in my head saying, okay, I'm dividing by a negative number. That means I need to switch the inequality sign around. Anytime you multiply or divide by a negative number, you flip the inequality sign. So that gets rid of the negative 2, and x is now greater than or equal to negative 14. So again, I'm going to draw my number line. Put negative 14 in the middle, some numbers on either side of it, and x is greater than or equal to negative 14, so that means it's going to be a solid dot, and greater than, so I want the numbers greater than negative 14, and that's going to be to my right. Part C is a two-step equation. I need to move my constant to the right side, so I'm going to subtract 7. And I get 2/3 x is greater than negative 10. So now I need to get rid of that 2/3 x, 2/3. And the way that we've been doing it is to multiply by the reciprocal. So that means I'm going to flip my 2 and 3 to make it 3 over 2. And I'm going to multiply both sides by the reciprocal. And what this does is this helps us cancel out because 3 divided by 3 is 1 and 2 divided by 2 is 1. So that helps cancel out our fraction. And I get x is less than. If you don't know what negative 10 times 3 over 2 is, we can get our calculator out. Negative 10 times 3 over 2. That gives us negative 15. So x is greater than negative 15. So now I'm going to make my number line, negative 15 in the middle, a couple of numbers on either side. and x is greater than negative 15. Greater than means it's going to be an open dot. X is greater than means it's going to move to the right. Alright, 10a. Graph the given inequality. Well, this inequality is in standard form, and we usually graph our inequalities in slope-intercept form, which is y equals mx plus b, so that means I've got to get y by itself. Our first step here is to get rid of x. So I have a negative 3x term, so the opposite of subtracting 3x is to add 3x to both sides. And I'm left with 5y is less than or equal to 3x minus 20. These two are not like terms. This is a variable term, this is a constant term. And then I need to get rid of the number in front of y, and it's usually multiplied, so the opposite of that is to divide, and every term gets divided by 5. And I'm left with y is less than 3/5, less than or equal to 3/5 x minus 4. And again, I've got it into slope-intercept form because I've got y equals, there's my slope, there's my y-intercept. My slope is 3/5. My y-intercept is negative 4. Dashed or solid? Well, that's going to come from our inequality sign. And if you have that less than or equal to sign, that equal to sign tells me it's going to be a solid line. That means it includes those points in the inequality. Shading above or below, again, that's going to come from our inequality, and it says my y's are less than my line. And since it's less than my line, I'm going to be shading below. Now to actually graph it, I'm going to start down at negative 4. 1, 2, 3, 4, negative 4. And I'm going to go up 3. 1, 2, 3, and to the right 1, 2, 3, 4, 5, and graph my next point. And keep repeating my pattern, going 1, 2, 3, and to the right 1, 2, 3, 4, 5. And then I'm going to repeat the pattern in the opposite direction, going down 1, 2, 3, and to the left 1, 2, 3, 4, 5. And going down 1, 2, 3, and to the left 1, 2, 3, 4, 5. Since this is a solid line, I'm going to connect my points with a solid line. That means it includes all of those points that are on the line. In my shading, y is less than my line. So here's my y values, and I need to shade below the line because that's where they're less than. And this shading means that every point that's being shaded in is a solution to the inequality. All of these points will work and make the inequality a true statement. 10b. Again, my equation is not in slope-intercept form, so I've got to get rid of x by taking the opposite sign, so negative 2x. And I get negative y is less than negative 2x minus 5. I've got that negative sign in front of y that does have to be divided out, and it's a negative 1, so I'm going to divide everything by negative 1, and I'm dividing by a negative, which means I've got to switch my sign around. So y is now greater than, negative and negative is positive 2x, negative and negative is positive 5. So my inequality is y is greater than 2x plus 5. So my slope is 2, my y-intercept is 5, dashed or solid. That again comes from our inequality sign. Since it's greater than, it is going to be dashed. And shading above or below. Well, y's are greater than my line, so that means I'm going bigger than my line or above my line, so the shading will be above. My y-intercept is at 5, so I'm going to start up at 1, 2, 3, 4, 5. And my slope is 2, so I'm going to go up 2 to the right 1. Up 2 to the right 1. And I'm going to repeat the pattern in the opposite direction. And I do have a dashed line, so this time I'm going to make dash marks through my points. And draw my arrows, and it says my y's are greater than my line. So here's where my y's are, and it's going to be above my line. So I'm going to shade in everything greater than my line. And that means all of these points that I'm shading in are solutions to the inequality. That means I can pick any point in my shaded area and it'll make the inequality true. And we are done.